Okay, so in this problem, we've got 8 particles, so capital N equals 8, and we're asked to work out the multiplicity of configuration for each of the configurations. So first of all, we've got the configuration with all of the particles in the first box and none of the particles in the second box. And we know that that is equal to 1. There's only one way to do that. If we wanted to, we could use our formula, in which case we'd have 8 factorial over 8 factorial times 0 factorial. This is just 1, but as 0 factorial means just 1, but 8 factorial and 8 factorial cancel out, so you can see that by calculation we can also get 1. Okay, the next option is n1 equals 7, n2 is equal to 1. So in that case, there's 8 different ways that we can choose n2, so it'll be 8. Alternatively, we can use this mathematically as well. And so this is equal to 8 times 7 times 6 times 5. So we've got just 8 left on the top because most of everything else cancels out with this 7 factorial, and 1 factorial is also 1. So this also does 8. You can check it on your calculator. Okay, then n2, the next configuration, we've got n1 is equal to 6 and n2 is equal to 2. And in that case, let's calculate it. We've got 8 factorial over 6 factorial times 2 factorial, and solving this on the calculator we end up with 28. So this is 28. n1 is equal to 5 and n2 is equal to 3 will be the next one. So that's 8 factorial over 5 factorial times 3 factorial. Calculating that on the calculator we end up with 56. So this is 56. Then we've got 4, n1 equals 4, n2 is equal to 4. And so calculating that, we've got 8 factorial over 4 factorial times 4 factorial. Solving that on the calculator, we get 70. So this is 70. And now we do them in reverse. So we've got n1 is equal to 3, n2 is equal to 5. And so that'll be 56 again, because you can see why it works in reverse. If we were to calculate this, it would be 8 factorial divided by 3 factorial times 5 factorial, and the order of multiplication down here doesn't matter. So we end up with the same answer. Then we've got n1 equals 2, n2 is equal to 6, and that's the same as this one, so 28. We've got n1 equals 1, n2 equals 7, that's 8, and then we've got n1 is none, n2 is 8, and that gives us 1. Okay, and then in the next part of the question, it asks us what's the probability of finding it in this middle configuration here. Okay, so to calculate the probability, it's equal to the number of microstates with the configuration we want divided by the total number of microstates. So number of microstates in n1 equals 4, n2 equals 4, over total number of microstates. Okay, so there's 70 microstates with the configuration we want, and the total number of configurations, we sum up these numbers. So we do that on the calculator and we get 256. So it's 70 over 256. We can write this as 35 over 128, or we can solve it on the calculator and end up with 0.273. So that's the probability of it being in this n1 equals 4, n2 equals 4 state.